خوش. Assalamu alaikum wa rahmatullahi wa barakatuh. We need to check if we have a connection and if really I am live. Just a moment. I think I need to update. Refresh page. Okay, we are live. Congratulations, we are live. I need to check the stop recording. No, I don't want to stop the recording. I want to check the stream quality. Oh, okay. It should be. We should be live. Okay, voice is low. Okay. It should be. We should be live. Okay, voice is low. Okay. Anyway, I think it's very bad to go to the YouTube from the same computer. Okay, we have a problem with voice, right? So voice is low. Voice. How about, what about now? Voice is, I think voice is good. So I need to connect my, I will connect my phone. Just wait. Streaming. Streaming is not easy, but streaming is very interesting. I'm very sorry because I don't have very good experience in this managing this stuff, so please be patient. Actually, why I'm doing stream, I want a help, therefore I'm doing a stream. I need your help. I need your help that you can help me. Actually, you can help me. I'm doing stream. I want a help. Therefore, I'm doing stream. I need your help. Oh my god! How can I see the? How can I see? You can help me. No, just wait. Not here. Because desktop Windows. Try to use microphone or AirPods or phone. Do I have earphone? Yes, I have. Do I have microphone? Yes, I have. Let's try microphone. I have one microphone from China. Wireless microphone. So I will connect it here. I will turn this on. I will attach it here. Okay, hello. Hello, hello, hello. Hello guys, hello. Can you hear me? What about now? What about now? Okay. Okay. Anyway, we have a one viewer. That's good. I think it's me. Or okay, Muhammad, yeah, Muhammad. Okay, so what we will do? Oh, this is competition. Pick up a new one. Please don't read this. So I need to quit it. Where is it? Oh, where is it? Open. Taking competition open. Oh, okay. It is. How can I say? It should be not in Steam, I guess. Okay. I put it here. I think it's fine. So if I don't mistake, it should be in fun. Readme. Okay, readme. It is our readme. It was our plan from last stream, which I did 2 days ago. Plan for today agenda. Batch normalization. For now, let's don't do this. Let's start from something a little bit easier. It's night, so if I no, I cannot do like this. As AI is developing and already it all changed. As AI is changing and this hype is going up and up, I'm switching, like I'm trying to go even back to old technologies. I don't know why, but I like it. So today I want I want with you to study how to detect AI generated text. AI generated text with in Python. No, like, language doesn't matter for us. AI generated text with deep learning today. Stay tuned, okay? So let me to give you the problem definition more more concrete and more whole image background of this AI generated text. So we have these LLM machines, algorithms, I like to call them machines. LLM machines which generate texts. It is almost identical with human generated texts. How to differentiate between them? What is the ultimate? Can LLM achieve such performance that it will be impossible to differentiate between human and machine generated texts? Very good question, you know. This last question is very, very good question. Can a LLM achieve such performance that it will be impossible to differentiate between human and AI generated texts? Oh, why? Because I didn't put insert. I am a little bit new to the Vim editor, so I'm using here it is Vim. I put insert, attach, I will delete, move it to the left, insert, delete, down. Who knows? Can it achieve? Maybe yes, but there will be definitely some kind of difference. I believe because we humans are like almost live in one distribution. We are different, yes, but we are in one space that we speak, we generate a text in this space. But LLM can go higher or it can be lower than this space. If it is lower or higher, then it means it can cross between, right? If I have a AI generated text which is like maybe one sentence, two sentences, it's very, very challenging to differentiate currently, right now. How to prove? Okay, we need to prove, right? For example, AI also can reason now, like reasoning, and we give to AI so much data, our data distribution, so that it imitates that things and it makes very small mistakes. For example, LLM like ChatGPT, for example, if it say today is a beautiful day, yeah, I can write like this. Human also can write. It's difficult. However, if we have a lot of text, we can somewhere catch this kind of strange thing, or catch here some kind of like unnatural or some kind of this awkward words in between. If it is too long, like it feels like too much, or it feels like there are too much sugar inside. It feels like not natural. And human is tend to make mistakes, like in writing also. Today is a beautiful day. Today is a lovely day. Let's check, for example, okay, so what is the problem? We want to detect AI generated texts, and if I don't mistake, I read from somewhere. What kind of, like, what was the name for detecting the AI generated text? There was like one program, right? This is distribution, right? Like, uh, I have heard from someone. I have heard from someone that LLM generates a text which can be which can be learned. Which no, I have heard that LLM generates text which has some statistical relationship, so it reveals itself. Usually we do this kind of like LLM does generation based on this softness, right? Like what token I should predict next, and the higher probability they choose is higher probability words. Each time when they select this kind of words, there is some kind of relationship or correlation, so that uh, uh, we can definitely catch it. I have heard, but I don't know. We should make some research. At school, what was the name, like when you have a assignment, and before submitting to assignment to a teacher, there is a process to check whether your essay or whether your work doesn't have what was the name, uh, phishing, no, not phishing, what was the name, I forgot actually, guys. Let's go to Safari. First of all, let's go to Kaggle. What is a Kaggle? If you guys don't know what is Kaggle, Kaggle means platform where you can find a lot of AI related stuffs. Guidance to using AI generated text on Kaggle. Guidance for using AI generated AI generated text detection. Okay. 3 years ago. AI generated and human accuracy. AI generated text detection. Cluster. Let's there was competition. LLM detect AI generated text. Okay, it was a long time ago. But we can read the code. Bro, did you know any coding before going to the university, or did you learn it from in Korea? He learned Python and some data science before coming to Korea. How about you? Did you learn it from before going there? Thanks. Okay. Um, Streamers, they are talking, not streamers, participants, members are talking with each other. I need to speak. I don't need to shut down. I don't need to be silent. So here, the Berta version 3 preprocessor, preprocessing text. And then what kind of model are you using here? Modeling. Keras library, BERT, Roberta, the BERT and more. Well, feel free to explore because of documentation, physics classification. No. Too much overlap abstraction there. Yeah. Now I feel a little bit lost, honestly speaking. But let's talk. Let's try to figure out how we can do it. So we have different models, right? We have statistical probability models. We can have a pre-trained model. We can have a decision tree. We can just have some kind of simple algorithm instead of training deep learning. Or we can just go to maybe Llama or this kind of big LLMs and ask from them advice and use their decision for doing some kind of pipeline. We have different ways, but we need a data set, right? So like on what data we will do these generations, these stuffs. Let's try on this data set. I do new notebook. I join competition. Okay, we need to sign in. Just give me some time. Here we have one new notebook. Join competition. Late submission. What? You cannot sign up. What? I cannot read it. Is it fine to do stream here? I think fine. I don't know. Actually, I don't like this. How can I say? This layout. Very strange. So here, detecting AI generated text. Okay, bullshit. We don't need anything. I have a philosophy before. Let's say, Bismillah. So, let's start now. We don't need this one. Here, we have a data set. Let's look to the data set. Sample submission, train essay, test essay, train prompt. Okay, we have here prompt also. We don't need prompt for now. Let's not make these things a little let's not make this thing complicated. So first, let's look to the train essays. Import pandas as PD. Import numpy. Maybe we need numpy somewhere, just in case. Okay. And df.pd.reads scsv, and it is where? I don't know the path, but I can copy here. Where is it? Okay. And I want to check what is the actual size of it. Df.shape. It's not too big. It's 1, 2, 3, 4 columns. and 1378. Ah, okay. Generated. 0 means not generated or false. 1 means generated, yes. So let's read 1 from the generated. Okay. No, let's read first from not generated, human generated text. In order to do that, df dot log 1. What is the ID of this text? 1012. 2. Oh, why? Or maybe I need to give the name of the column. Yeah. Oh, it's plenty. It's actually it's long, right? It's quite long. Transportation is a large necessity in most countries worldwide. With no doubt, cars, buses, and other means of transportation make going from place to place easier and faster. However, there are always a negative pollution. Although mobile transportation are a huge part of daily lives, we are endangering the earth with harmful greenhouse gases, which could be suppressed. Okay, enough. df.log, I can say df generated equal to 1. So now we have this all generated with 1, and I can read text here. If I do like this, no. Alright, if I give index maybe 704, no, error, key error, key error. Dot look. Let's do like this. Okay, now this essay will analyze, discuss, and prove one reason in favor of keeping electoral college in the United States for its presidential elections. They don't have to vote for their own state's nominee unless their state has a winner-take-all system. However, there are states that have adopted laws that force their electors to vote for their state's candidate. It seems that no matter how electors are not bound to vote for the candidate who won the most nationally. This is not always the case because the state legislatures who can overrule the electors and vote for the alternative candidate their citizens have selected for them, even if the voter lives in the state without a winner-take-all system. What? Doesn't make sense for me. It seems very complicated. Okay, we have this one, and we have a submission, right? So let's look to the submission. Submission. I think it's just ID and stuff, and the whether it's 0 or 1. What? Only 3? Really? Only 3. AAA, BBB, BBB. Why it's like that? So wait, we need to read it. it's not good. Something wrong here. Okay. Oh, I see. Why there are only three? Three. Why? Only three. Ah, plagiarism. Plagiarism. Let's look to this guy, what he's doing. On time. We have ID. Third classifier. Training. Training what? What's he importing? Bird classifier. Okay. Encoder. What is encoder? After model. Pretrained model. Name. Bird classifier. Hmm. SSS. Test df equal to pd read c3 and test df dot shape. Really, it's only three? It's only three? And text is like this? Strange. And what I need to submit to the edition? Late submission. We will rerun your code. They will rerun my code on their private tests. That's it. So don't worry. Don't worry. What kind of simple thing we can do? the simple thing we can do is what? Simple model. We need just very simple model, right? We just need very simple model. I can make a vocabulary list. No, like not vocabulary list. What I mean is that I have a text. I need to represent this text in order that my computer can understand. For that, the best or efficient way is to use some kind of tokenizer to convert into the numbers to the tokens. But why I am given a training set? What is distribution of the training set? df dot log df what generated equal to 1 with shape. Okay. Oh, really? And df dot log df generated. Oh, I am having a call. Just a moment. Hello. Yes. Data vergano. Akıl brother. Karşı katı çıkan internet. Okay, bye bye. Sorry. Okay, here we don't have this kind of, like we just have three examples for generated, and we have all other things are from human. Okay, we need to use some kind of logic, right? We need to use some kind of logic. We need to use some kind of logic. What we can use? We should think carefully. We should think carefully. Assume I have this model f function. Okay, I pass my for example, let's say 10 words, okay, to the my function, to the my model. My model says value between 0 and 1, right? For example, here's my text, for example, lovely day to you, and I pass this to my function, and it says 0.1, which means it is 10% probability that this, not this, given text is a AI generated, right? So this is our basic logic, okay? This is our basic logic. So what we need is that we have this lovely day to you. We need to convert to some kind of numerical value, and this numerical value should be given to our model, our model should compute some kind of inner process, and in the end give some kind of softmax or sigmoid or some kind of probability in the end. What kind of like we need to use now some kind of tokenizer thing. Tokenizer kind of thing for this. Problem is that I don't know whether his test data set has a, how can I say, whether his test data set words inside his test data set will be inside of my vocabulary, which I will now build. Yes or no? I don't know. So if I don't know, one good thing to ask yourself is that what kind of minimum action or progress I can make in this situation. So in this situation, the minimum thing which we can do is, I think, just let's count the unique numbers of words inside this dataset. So df text, right? So we have this much text, and if I use values, it should be all. It's just one. Oh no, it's array. It's array. Okay, it's array. Okay. Text. And now for text in text. Okay, here's a bad thing. For text in text, for each essay, I want to count unique number, right? Unique forward in text dot. So it is this txt. I believe it should be string in Python. If it's a string, I need to split it. Okay, first of all, let's don't make these things complicated. So we have this text, right? So I can say split word by word, right? And we have also strip action. Strip removes special symbols like this kind of symbol, or it removes this kind of symbols, etc. Do this, doesn't matter. Okay. Strip split and word equal to word dot lower unique word unique. It's not suggesting word list dot append word. Why if word not in unique words list. What? Okay. I have a low battery. I need to charge my computer. Okay. We have this much words. We have this much words. Okay. And then what? Then what? Do you think that AI always use common words, but human use different natural words? Is it something like that? Behavior text, then what? Then what? Then what? Then what? What? Actually, human. We have here AI, and here we have human. Okay. Then question: how we can differentiate? We can teach a simple model patterns, like this kind of pattern is common in machines, in AI, so it is AI generated maybe. Or if there is like if certain words are used a lot in this essay, probably AI maybe. So in deep learning, as you know, in deep learning, what we do, we give an opportunity to the algorithm to catch patterns from the data. Okay. Oh, what I did? No. Mistake here. Catch patterns, right? Okay. Can I solve the problem? Yeah, currently. Do I have an idea? No. Do you have? No. If no, we should go one stage down, below, to the simpler problem. Okay. So why we don't have idea? Why we don't have idea to process to the next step? Because we are lost clear image, clear idea. Let's go back again. So we have the text, we pass to the function, and this function gives us the probability between 0 and 1. Simple. So here we have data set. So now we need to try the simplest method. The simplest method is to give maybe to count the words. Yeah, simple method is a count the word. So we need to count the words for AI and for human. What is the top? We should count for each word. What is the frequency? What is the probability that the ordinary like ordinary statistics to say what is the next word usually comes in human text versus to the AI text. However, here's a problem that we don't have much AI text. We only have 3. All others are human texts. Here we don't have data for the good data for the things classification, right? In this data. No, actually we have only 3. Let's look to this. All of these 3. This essay will analyze. I strongly believe that the electrical college limiting car usage cause pollution, increases something. Okay. I have prompt ID. Do we have a prompt? Oh, I mean, like, we have trained prompts. Let's look to the prompts. Prompts. Are free cities. Huh, interesting. I have no idea actually. Let's look now. Like, source text, instructions, prompt name. Its prompt name, it is prompt. It is raw data. Let's look to it. Prompts df.ilog 0. Integer. We ask from you integer. Give me integer. Here you get 0, 1, 2, 3. 3. You saw, see, if I put I, it means index maybe. It refers to the index. Then we need to give 3. Okay, here we did small discovery, guys. Here error. Here I need to pass column name. See? I prefer first one. Simple is best. Okay, it is generated, I think. It's not the speech, it's just the text generated from the LLM. Prompt name, what is electrical? A source text is same. I don't know. Let's look to here. What's that doing? It's this data set. It's we don't need this one. Here. So is that training? So right? For training, they are auto tokenizer, tokenizing, and passing the tokenized to get item, and it's tokenizing and returning the input ID, attention mask, label. So they are using this. So this guy, not they, this guy, and this guy. This guy is using where? Not here. Not even here. Auto tokenizer. We can also use it. Do we need to import? I think no. Okay, good. Oh, what? I didn't complete. Let's check now. Okay, now very good. I don't care about you. We need a reference, okay? We really need a reference. We need a reference. So we have a tokenizer, and I want to get this tokenizer. Truncation, padding, max length, and the max length 256. Okay, text ID. So now here's the tokenizer, and that is text. I need to pass only one word, I think. Yes. I myself make things complicated. Word equal to text.0. text dot split. Yeah. I think it should first download these things. Yes, downloading. And then encoding, return. Oh, done. Maybe it seems like done. Yes, done. Now we have this encoder, and now we can do some kind of funny stuffs. Touch, label, ID. What kind of ID are you talking about? Attention mask? What else we have in encoder? Encoding. Second tab ID. How is this tokenizer is working? Why we are using Alberta? Why we are using Alberta? It's not speaking up. Let's read this. Input ID. What is input ID? Input IDs. How can I get help? Tips. Okay, guys, I need help. I lost. I got lost here. Tension mask. Attention mask, attention mask. Actually, Alberta is just a BERT model, right? BERT is what? Encoder only transformer model. Hello, hello. Okay, now. Okay, now I think you can hear me. Output. What kind of encoder this? Self. Of course, we don't need this. We don't have. We don't need this kind of strange self. Not enough value to unpack. Unpack. Okay. Okay. See you. Okay. Bitti. Yep. Bye bye. We have here in. Okay. We have loaded everything, right? Like until here it's working. But when I use encoder, this guy, and pass these two things, it's saying what? Value error. Not enough values to unpack. Expected to got 1. Expected to. Really expected to? Squeeze makes it small, right? Maybe we don't need squeeze. Maybe it's because of this problem with shape things. Yes. So now, why shape? Because it needs one more extra dimension. Without pulling, I don't care why you give me a pulling. So what is the output type? What kind of type is it? What is this transformer based model output? It's special. It belongs to this class name. But I want to check the shape of this output. What kind of output it is? Arguments, last hidden state. Like this, right? Output, last hidden state. So what is this? We have the encoder. We put to the encoder input ID and give attention mask. An encoder do some kind of computation and it gives us the output. And when I check the output shape, it is 1 and 124. 24. Now you see how stupid I am. So actually, how was the small simple model is work? How it was working? So we convert to the text to the tokens, and we use embeddings. We move it to the embeddings. What kind of embeddings? How? What? And after embedding, we have a positional embedding and token embeddings. I think now it is token embeddings, and now this is output from embedding, and the output I think it's almost all 0, no, a minus. Does it has this kind of this kind of attribute? No. Hey, 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 hey. This is just encode. This is embedding. So afterwards, after this encoder, we are in this embedding layer. Okay, it's 12:43. It's late, so it's for now. This is enough of stream. Actually, we didn't make a big step. Here we need to repeat a little bit about encoder, embedding, tokens, how it becomes, how it converts to the numbers, to the embedding, and how positional is calculated, and then we can make a good progress later. So here, that's it for today, guys. I am stopping the stream. Thank you very much for guys who joined and who watched. Please be online on YouTube. I will try to be more consistent. For now, that's it. Like this kind of small steps, and we will like grow together, do some kind of bigger things. It's late night for me. Yep.